Hello, Hathorians, and welcome to episode 3 of Tech Talks. We're joined by Marcelo, co-founder and CTO of Hathor Labs. Marcelo, how are you?
Oh, hi, Neil. I'm doing great. Thanks for having me. How are you doing?
I'm doing very well, thanks. I know you've been extremely busy. Everyone has, myself too. But it's great to have you on your forum, Tech Talks. Love having you here, getting some time from you to kind of go through a few things. Tech-wise, of course, we love talking about new tech and also about, things where we've been working on. So thanks for making the time.
Of course, it's a huge pleasure to be here talking to you. I mean, last time we spoke, it was what, end of March, beginning
Yeah,
of April, maybe?
yeah, a few
So
months
it's
ago.
been like quite a few months, and wow, we made like huge progress. So there's lots of things to talk, to discuss, and it's like absolutely my pleasure. And I'm very happy to be able to come here to talk about all the things that we've been doing and what's to come. So yeah, thanks again, and I hope our audience enjoys the content.
I'm sure they will. I guess we always say we need to do these things sooner again because by the end of the episode, we're always so excited to give more. But honestly, after this one, we should get another one out sooner. So it's great to have you back.
Okay,
So
deal.
Marcelo, yeah, deal. So Marcelo, just to kind of recap, actually, how we're following from episode 2. In the last episode, you did mention quite a few follow-up points, and as we mentioned, actually, I may as well just read the question now. The first question is surrounding those follow-up points, just to kind of give us a quick fire update on a few things that have already been communicated, but new things as well. So yeah, let's just follow from episode 2 for our new viewers who may have watched your episode 2, want to go into episode 3 like it's a Netflix show to see what's coming next, and just flow well from the deliverables we've said that we're going to be doing from the end of the last episode.
Okay, sounds great.
Awesome, awesome. So the question is, I'll read it out to you. Last time you were on Tech Talks, you outlined quite a few deliverables and next steps for the coming months. Since then, a lot have been delivered, and to basically kick things off, I'd like to go through these like one by one to give an update on where things stand. So the first one is code freeze.
Okay, yeah, last time we spoke, we were really close to get to code freeze. And wow, for me, because I've been like working deeply into this, it feels like code freeze happened like a century ago.
Yeah,
It's like it's been so long. So yeah, I mean, we reached code freeze, which basically means we reached like many months ago, which basically means that we are not adding any new features. We are just fixing and improving the code and testing, and we've been doing this for a while. So
yeah,
I'll wait for the other topics because we're
yeah,
gonna certainly touch
yeah, sure.
things that happened after code freeze. But yeah, it was achieved
Amazing.
several months ago, and yeah, for me it's like it's kind of funny because I'm kind of surprised because for me it's something that happened like a long time ago.
Amazing. Yeah, it is. It's quite surreal to see how much time goes by, but how much so much gets done. They always say like in the Web3 space, a week feels like a year, or a year feels like a week. But it depends each or so it's one of those things, right? So yeah, moving on to the second one, which is surrounding security audits. Actually, on the last episode, again, it was more of a discovery stage. We hadn't announced who the security the partner was, security audit partner was. So yeah, based on security audits, take the floor.
All right, yeah, security audits is like I'd say the very next step after code freeze. So because we're not adding new features, so what are we doing? So basically, we have like two fronts for security audits. One front is an internal audit that's made by our team, and I myself, I'm working together with the whole team. So that's internal.
Yeah,
That's one front. The second front is to work with an external auditing company. We chose Halborn. They are really, really good. It's been a pleasure to work side by side with them during their internal audits. So about the progress, because it's been happening for a while now, Halborn finished their audit this week, and they are preparing a report. They haven't shared the report yet. I'm waiting for it, but they've already advanced to us that they haven't found anything major. There are minor things there. But yeah, I'm waiting for them to share the reports, and we're going to really deeply, thoroughly, and go through any points that they have raised and discuss with them what can be done, what fix, and those kind of stuff. That's the very, very next step in this front. And in our internal auditing, we have a list of tasks that we'd like to check, double check, triple check that everything is in place. And we're doing this. It's moving really good. It's moving really well. And we expect to get our internal audit finished by the end of the next week.
Oh wow.
So it comes together that we are internally getting to the end of our audit, kind of together with when Halborn
Wow.
is finishing their work too.
Wow.
Halborn basically, it's the same for us, but this audit basically covered uh, uh, all new features that are coming with nano contracts and all the core components that the nano contracts touch, like the consensus and the interaction between UTXO and account-based model. So basically, it's sending, transferring tokens between the UTXO, like an output to a contract, and how the contracts can use it, transfer to another contract, all interactions that can happen there. So the audit covered basically everything, including some parts that we're going to talk about it later. Probably if you don't, I'll add those. Dev experience, how we can protect developers from making mistakes,
Yeah. Yeah.
so they don't get robbed, they are not attacked.
For sure.
So yeah, we're gonna cover this, but
Yeah, I
go
think
ahead.
in the second section is really covering security and
Okay, perfect.
yeah, I think it does because there's two sides, right? There's protecting the dev and also protecting the user, and I guess both are extremely important, especially with nano contracts and onboarding waves of devs for them to monetize and so on. You have to protect them also, right?
Yeah, and I'd say that it's one of the, at least for me, we're gonna dive deep there after, but providing a safe environment for developers, I guess it's a huge upside from nano contracts comparing to other solutions because I mean, it's a decentralized network. Of course, there are ways to stop now. All platforms are adding ways,
Yeah,
and contracts are preparing for the worst,
yeah,
for the worst case scenario. But still, usually attacks can steal lots of
yeah,
funds. They unfortunately they keep going. They keep happening. And we want to provide, like, that's one of the major goals with nano contracts,
yeah,
to provide a safe environment for developers,
exactly.
even or including non-blockchain experts. So
Yeah,
developers from other areas that are coming to develop, adapt, or working, or part of their solution is running in a blockchain like ours.
we'll definitely touch more on that in the next section. I guess reentrancy is one of them, but it's on the list actually below. So we'll
Yeah.
definitely come back to that. It's an extreme.
Okay.
When we get into the tech side, it's like a can of worms. You can't stop it, right? So it's amazing. It's amazing. We've got a couple more from this previous section. The next one is basically the final nano contracts testnet and the merge of the code base.
Okay. Uh, that's something that happened in parallel with the security audits. After the code freeze, we started doing the merge. What was that? We had a Hatter core, which is basically the full node used in mainnet, and we're coding a separate repository, Nano. So because Nanos, during the development, we could add bugs and issues. So we were doing like in a separate repository. So we had two code bases, and we had to unify these code bases, and that's done. So now we have one code that covers everything. So basically, the mainnet now is running with nano codes but disabled. The activation is going to be the launch. So we have one code base that has the whole thing. So that's part of this. What you're talking about, getting like to a single code base. It's
Yeah,
done.
yeah,
The next step that's done as well is to have to use this code, this final version unified code base, to run a testnet. So basically, we did two things. We launched the Bravo Nano Testnet,
Yeah.
which is using this new code. And this network has nano contracts activated since the beginning.
Sure.
And we upgraded actually our official testnet. We had the Golf testnet, and
Mm.
now we launched the Hotel testnet. That's the
Mm.
new official
Yeah.
testnet, where we actually have already activated nano contracts there.
Okay.
And that's a subtle but very important difference
Definitely.
because this activation process is exactly what's going to happen when you launch in the mainnet, when we launch it to production.
Yeah.
So the activation uses the feature activation flags in the
Yeah.
node. So it interacts with miners and wallets and the explorer. It's like uh, 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 a whole thing to get new features into the network, and we configured it into the hotel testnet, and
Yeah.
it activated last Saturday.
Oh, amazing.
So it was August 2nd, I guess,
Yeah.
and it's been working very well. So it's very
Amazing.
important for us because it was the very first time where we could test the whole activation process
Yeah.
and how everything would work together,
Yeah.
and it was a success. So we are still running tests there, but so far it's been really good.
Yeah.
I'd say that's a major achievement because we need to do this in a test net before doing mainnet. So
Yeah.
I can confidently say right now that the activation in the mainnet is gonna happen like smoothless. It's gonna be like really simple and smooth for everyone involved. So I'm pretty excited about that. But yeah, so in this front, the merge of the code base has been done. The test nets are in place. We are keeping the Golf testnet alive just in case, because right now in the hotel testnet we have nano contracts activated. That's where the mainnet's going to be after the activation. But right now the mainnet doesn't have nano contracts. So if any use case would like to test without nano contracts, we're
Yeah.
like they can use Golf, but it's not our official testnet anymore. We're keeping it for these other use cases if they want to
Yeah.
run tests.
For sure.
But hotel is the one. Nano contracts are activated there. And now the next very step is to finish the security audits,
Amazing.
get the reports, wrap things up, and then we are good to go. We are
Yeah.
clear to launch in mainnet.
Amazing. Amazing. Yeah. So golf, and you've got hotel, and I guess to put it into layman's terms, and you said it's basically like hotel. The feature activation, by the way, it's been a while since we spoke about it. I remember when that feature went live, we wrote a blog on it, So it must have been
Okay.
nice to see it go live, and because I guess the feature activation is important to get all of the partners and all the node runners ready for any new features on the network, right?
Yeah,
That's the reason why.
precisely. The feature activation is a way to upgrade or to add features to a blockchain
Yeah,
network, because peers, all participants in the network, they need to update their full nodes, and they can't do it like simultaneously. As a blockchain is a decentralized network, people need time, and they're going to do each company, each partner is going to do their upgrades at their own pace. They have QAs and processes and internal testings that they must do every time they upgrade the network. So that's the way that we allow everyone to upgrade, and then when the network has agreed that it's upgraded enough, then the feature activates and everyone can start using it.
okay.
Otherwise, there would be like a hard fork or something.
Yeah, yeah,
So that's the way. And we have already activated other features before
yeah.
Nanos, but definitely Nanos is the
None of
largest
the
one,
the largest one, I guess.
the
Yeah,
most important one too. Yeah.
most important. Yeah, I guess as you said, to wrap that section up, I guess the hotel testnet is basically a direct replica with the nano contracts. Uh, Golf has
That's
the network,
perfect.
yeah, and it's almost like if it's all great, it's a flick of the switch, right? Because it's an exact replica of the mainnet. And but as you said with golf, golf runs extremely well, so there can be definitely a great use for it in other environments with use cases, as you mentioned, and so on. So it's good that, of course, these things are being built but being used and have value. Like we see value in different environments for you never know when you'll want to test and use these environments again. So it's nice to see them. Definitely a great thing. So thanks for touching on the merge of Codebase and the hotel testnet for the community. I'm sure that's the first time they're hearing about that. And guys, it's a flick of the switch. So I
Yeah,
guess
yeah,
the last
it's really good to see that we are as we planned before, but we're using everything that we've been building the last years.
for sure.
This is a separate act. The feature activation is a separate thing. It's not like it's not really part of the Nano code, but it's a feature that's needed to activate Nano in mainnet in a
Yeah,
safe
for
way.
sure. In a safe way. And I think touching back on what you said before, um, protecting developers aside, but you know, everything we've built literally brick by brick is to make this architecture like a cathedral. You know, this blockchain is like a cathedral. We're not putting up uh I'm in Dubai and they put towers up in days, you know. So we're trying to build a cathedral here, you know, it's great, you know, getting to the top of the cathedral now and a base that is extremely beautiful. So I'm sure from you guys' side as developers as well, when you take a step back and you see all of this code, like for us, it may be code, but for you to see this all working simultaneously and having purpose and fulfilled certain things, I'm sure it must give you guys a
Yeah.
sense of
And,
achievement.
and here we are basically covering the full node part. They're all the clients, the wallets, the APIs, the Explorer, the dApps, the MetaMask snaps, the Wallet Connect. Wow, there are so many moving parts, and everything is progressing together. And I guess it's going to be a very successful launch. I'm very happy with what we're building.
So am I. It's great times ahead. And I guess before we move on to the more technical side, the last point I wanted to ask about was probably the main one, which is the activation plan for mainnet.
Well, the requirements are to get the security done, the security audit done. We're almost there, I'd say. Um, to get the code, the merge, it's done. To get the test nets, they're done as well. So basically, I guess we're waiting on the security audits to finish. And then what's going to happen is that we are going to create a feature activation with a whole description, and I'll explain it. But and we're going to release a new version of the full node. This new version must be all partners must upgrade their infrastructure to
For
use
sure.
this new version.
Sure.
With the feature activations, they have time to do it. So we are talking to them to see how much time they need. Should we give them like 2 weeks, 4 weeks, how long they need? Because each company is different.
Different,
So all exchanges, mining companies, miners, mining pools, use cases, and the ones that are going to launch too. So Dozer is one of those, but we have the other groups from the grant programs. Uh, uh, so everyone must upgrade. It's a must. If they don't, if someone doesn't, they will hard fork very quickly after the update because we're going to use it kind of right away. After it's activated, we're going to start using it.
sure,
I guess nanos. That's what I'm
sure.
saying. So the next step is like to the release is like to release a new version of the full node and notify everyone, please upgrade. But after the release is done, it's gonna like there's gonna be like a date where the activation is gonna take place.
Yeah,
So on our end, it's more about supporting the community, supporting the partners in any issues or questions that they have,
sure.
but there's not much to do. We're
Yeah,
gonna just like sit and wait for the dates to come.
amazing, amazing.
And this is a period where everyone is going to be upgrading and running tests. And if they are going to use nano contracts, they have the hotel network to test their blueprints and their integration with nano contracts while the mainnet is upgrading.
Amazing, amazing, amazing. Yeah, thanks for that. I wasn't really expecting that, but that's great. You know, so it's great. It's great. And I guess like you touched on feature activation. You touched on all of these things. I think to come to mind because, of course, like use cases as well as exchanges, they all need to get ready for this, right? Like because this is like it's almost like you know the nodes are like parts that you must equal the same side. If it doesn't, like you say, it kind of forces a hard fork. Everything has to be updated so they all work together. So yeah,
Yeah,
it's
it's the main difference between a decentralized network and a centralized. When networks are centralized, you can easily coordinate with the partners and everyone upgrades at the same time, and that's it. But in a decentralized environment, that's not how it works. So even though our internal Hatra Labs full nodes are going to be upgraded all at the same time and very quickly, it we are just a small fraction of the network. We are not
yeah,
the network. So we
definitely.
have to notify and give time for people to receive the notification, work on their end,
Yeah, for
run the
sure.
new node, sync, test,
For
run the
sure.
internal tests, and really do the upgrades
Yeah.
before we activate it. That's the whole thing.
Yeah, I guess you have to account for people in different time zones, different days. Like time
Oh,
goes fast, time
yeah,
just
yeah,
goes
yeah,
fast. Like
yeah.
there's only so much you can do in like a couple of weeks as well. So that's why, guys, the feature activation as a process is so important. So I've
Yeah, and they
definitely,
have their own backlogs of their own tasks and
yeah,
stuff. So we are just like one more in their task list.
yeah,
So sometimes it takes a while for them to get there to do the upgrades, and so they need time. That's my point. But after this release is done, the release of the Hatter Core with the feature activation for the mainnet, after this is done, on our end, there's nothing else to do. Of course, we're going to keep working on other projects, but mostly I guess we'll be supporting and helping all companies and use cases and whoever runs a node if they have issues to get everything up so the activation happens successfully.
amazing, amazing. Well, guys, that was a summary of the follow-ups from the last episode. Marcelo, thanks for touching on those points. I think you've covered them extremely well, and we look forward to bringing you this episode. We'll try and cut them into some shorts as well, so you guys can kind of digest them on X and share them. So thanks a lot for that. Really bullish stuff. And moving on to the second section. Now, the second section is again, I've written a question here. It covers into a few more features here that I've really never heard of. One of them we pushed some content on like last week, but otherwise, I haven't heard, and that's great because I'm here to learn. So the second question is for someone coming from other smart contract platforms, what makes nano contracts different in terms of both development experience and built-in protections for developers writing the code and users interacting with it? So I guess to make a segue into this and for you to go forward, the first point I have here is a Python VM. So there's a couple of points there that I want you to touch on, but give us an overview on what Python VM is. Like even for me, first time I'm hearing of this term. Tell us what is Python VM?
Okay, just before jumping to Python VM, this topic, this discussion, I guess it's crucial. It touches on so many decisions that we've made for nano contracts about how to compete in the Web3 environment. And so I'm just saying that, of course, we're going to discuss these topics here for a while,
Yeah,
but
yeah,
maybe
sure.
it's worth like a whole episode just about this.
Yeah, yeah, yeah.
There's lots of fronts to cover, and it's not about launching nanos or when it's going to be live or this kind of stuff, but it's more about how we're going to compete and why we believe that we are offering a piece of technology that can win
Yeah,
or can grab a share of the markets, can
yeah,
attract developers, can attract use case, and this kind of stuff.
yeah.
And there's a lot to it.
There is,
And
there
there's
is.
one thing that we can cover in this other tech talk which is like how the idea of nano contracts evolved over time.
Yeah,
Because actually it started back in 2019, and wow, I in 2019 I had no idea that we would get to the point that we are today, feature-wise. Nano contracts is way more advanced and sophisticated than what I thought initially. I guess it's good. It's not a bad thing, but wow, it's like way more.
Yeah.
And that's something that we can discuss in another
Yeah, yeah,
opportunity.
actually, yeah. Like before you head into Python VM, I guess even in the last episode, we really had intention to give even MEV its own episode, and such as with work and deliverables, we're on another episode having to still highlight a few other things, but for sure we should definitely do purpose-driven episodes on even just one subject. So it's great that you've updated us on all the amazing things, but definitely on upcoming episodes, we should definitely focus on a particular tech.
Okay.
That's how you
Okay.
want to
Jump
keep it talks.
jumping to your point, like
Yeah,
about Python
Python.
VM,
Yeah,
the Python
sure.
virtual machine.
Okay, virtual
Uh,
machine.
that's something that wasn't planned like 2019, and I guess it gives so much power to nano contracts for different reasons. So first of all, what is the Python virtual machine? Basically, we are using the actual Python engine to run code. So far, according to my research, other chains they don't do this. Some of those they do support Python, but what they do actually is that you can code in Python and it's going to compile to their own bytecodes, to their own virtual machine, and they're going to run there. Uh, uh, so it's a whole new environment on their own engine, which
Yeah,
is a separate engine not related to Python at all,
yeah,
except the syntax. That's not what we did. What we did is that we are actually using the Python machine to run the code. And it gives like, in my perspective, my view, like lots of advantages. One is that the Python engine is very complete, powerful, well-known engine. So let me go. Powerful because it's very easy to build sophisticated things.
yeah,
Because Python is a very high-level programming language, extremely dev-friendly. It's one of the most used programming languages today. It attracted many people from other areas who are not like computer engineers, computer scientists to the area because they can do things without having a deep understanding of how a computer works. So it's really amazing what Python could achieve. And that's one of the things that we'd like to achieve with nano contracts, to invite, to extend uh, uh, programming for blockchains to regular non-blockchain coders, not only for blockchain experts like other networks do. So the engine is really powerful. It's very easy to build sophisticated things, and it's true for nano contracts too, because we're using the Python engine. It's very easy to build sophisticated things. Uh, uh, and it provides also, we're going to touch this, I guess, when we discuss about the reentrancy and other
yeah,
stuff, but
yeah,
it provides a very safe environment
sure.
because the Python VM, for instance, has like unlimited integer size. We also, of course, we put the limit on it. Nothing's unlimited actually, but there's no issues like overflows, underflows, and those happen in other EVMs, and many attacks exploits those kind of things.
Yeah,
They simply do not exist in the Python engine. Of course, there are many challenges to use a Python engine in a safe way, uh, uh, but we manage those. So we found solutions, and it's safe. And yeah, that's basically Python VM. I can
okay.
spend like a lot of time discussing how we're running. I'm just not jumping there, so it doesn't
Yeah,
take too
sure.
long. But definitely we can dive there if you want.
Actually, yeah, before you stop on Python, yeah, just so I understand, I guess when you compare it to, I guess we're probably, as you mentioned from your research, the only chain probably doing the Python VM, right? And that's probably, from what I understood from you, the original way. But other chains, I think I know one off the top of my head, but they claim to be coding in Python, but what you're saying is they kind of adding a layer to their existing base to writing Python, but
Yeah,
it's
they are using the syntax of Python. So you look at the codes and you see Python, but the actual execution happens in a separate engine, their
okay.
VM, their virtual machine.
Okay,
It's not the Python virtual machine. So, and their engine is subject to lots of decisions that they made, and those are usually where many attack vectors come from.
sure,
They
sure.
know, okay, I know Python has this protection, but their engine doesn't.
Yeah,
So if I do this and that, I can try to overflow here so I can steal funds there.
sure,
That's
sure.
usually how attacks happen.
Yeah, definitely.
And we are not doing this. We are not creating a Hathor virtual machine. That's not true. We are using the Python virtual machine that already exists. So it's very well tested
Yeah.
engine and broadly used by many companies and platforms. And we
Yes.
chose Python because it's extremely dev friendly and well known.
Yeah. I mean, to be honest with you, from what I understood, it's like every layer you add is a risk, I guess, and doing it on the core that, like you said, the Python virtual machine is the same that anyone would use who code Python or probably be more familiar with. And obviously, it's the original, it's the safest because it's already like, again, my original point of not having layers on top, I guess, those layers always you can find backdoors or anything like that to attacks and stuff, right? Is
Yeah,
that
that's correct. And the layer also works in a way that it kind of tricks the developers because a developer he looks at the Python code and he reads the code and he says, okay, it works. That's it. It's
yeah, yeah,
correct. But if the execution engine is not exactly because when they say it works, they have like an execution model in mind.
sure.
They think, okay, Python works like this. I've done it several times. It's supposed to work. There's no way that someone can exploit this.
Yeah, yeah, yeah.
And but the execution is a bit different, so you don't see exactly what's going to happen, and that's where attackers can exploit the code. So they look at the thing, they say, okay, here I'm simply adding a number or I'm multiplying a number, and they say, okay, in Python, uh, 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 there are like unlimited integers, like there's no limit. They call it in the computer science, they call it a big int or a var-int and a variable size integer. And what happens basically is that that's not true. The EVMs, they have overflows, they have underflows. Uh, I can give examples about how
Yeah,
this
yeah.
can be exploited, but it gets really technical.
Yeah.
But my point is attackers they they have an advantage where the developers they look at the codes and they have an execution model in mind, but that's not true, and that's where attackers can exploit the code. Of course, after a contract is attacked, in the aftermath, the developers they understand what went wrong, but it's a shame that they couldn't see it beforehand
Oh,
and
yeah.
fix it before. Yeah, that's the point.
Yeah.
So we are providing an environment that's way more predictable for developers.
Okay.
They know how the execution is going to take place.
Yeah.
So usually, if they see something and they think, okay, it's safe, it's probably safe.
Amazing. I think we do need an episode on Python in general, whether it's
Okay,
Python VM. But you know
I
what's
agree.
interesting? Like, before we move on to the next one, whenever we're at events or we're introducing Hathor to, anybody, um, whenever we say we're Python native or our smart contracts are Python, people get really excited. They're like, "Wow, I've never heard of that." Like, it really like not triggers them, but they really like what like they almost could you repeat that? And it's interesting. We this sort of content and education is super useful, especially for onboarding the next wave of devs. Anyone looking to really build on something safe that will protect the developers, but easy as well, built for the web 2, built for anybody learning in school, whatever it may be. This Python VM, right? So I think we do need an episode on Python in general because that's one of our attributes we always stick to and we have over the years is that we're a Python native chain, as well as being a hybrid blockchain and DAG. It's being written in Python, so I think it's a extremely, it could even be a series, again, it's a great topic. So
Yeah,
thanks.
I agree completely. Not only the Python virtual machine, but the whole execution engine behind Hathor and how things work behind the scenes. I mean, we are building everything in a way that developers don't need to understand this to build. That's important to highlight. They don't need to understand what's happening behind to build a safe dApp. That's one of the major goals that we are looking for, that we're trying to achieve. But it's quite interesting to understand what's behind, how things work. So yeah, I'll be happy to have this with you.
100%, 100%. I'm gonna write that one down now. I think it's super important. So yeah, Python virtual machine, guys, you've learned something today, and we'll definitely be bringing you more content on that. And moving on to the next few, I know, Marcelo, when you and I are on a chat, we can talk for hours. So we're running good time. We're 43 minutes in, so we've got a few more points. The next one I actually want to talk about is reentrancy protection.
Okay.
This is actually going to be the first time we're actually talking about it in detail. We put a thread about it out earlier this week, but really an overview about why it's important. Who's been affected by it. Like there's almost $1 billion lost by this reentrancy exploitation. I guess there's also quite a cool article by Cointelegraph out that if any of you guys want to read about, you can. But we'll be releasing our own blog on this. So I'd like to get more info on, especially like your thoughts on reentry protection and how we're going to combat it, how it works in that stance, and basically anything you kind of know about that type of exploitation.
Okay. Yeah. That's as I said, like protecting the dev. So non-experts, non-blockchain experts can safely build is one of the major things that they're looking for, and that's part of it. So reentrancy attacks are very common, and many contracts have been exploited using them. It's an attack vector where, for the developer, it's kind of non-intuitive because the developer many times they're doing some operations and they think, okay, so the next line of code is going to be this, and then the next line of code to be executed is going to be this one. So when developers are reading a code or writing a code, they have like a sequence of things that they're doing. And what a reentrancy attacks does is that it can, one of the lines, if it's a call or indirectly a call, it can invoke another contract that can recall that method from beginning, and the next line actually is not that line. It's like something that in when they're coding for services, centralized services, non-blockchain software, uh, uh, they don't have to account for these things because this is something that's not going to happen. It's
Yeah,
basically impossible to happen. But that's not true in smart contracts. This kind of thing can happen, and it's more than that. They happen, and that's where developers they code things. If you want to, I have one example in the Hathor repository of a reentrancy, how a reentrancy attack would work. We can share with the community. You
yeah,
can
yeah,
show.
yeah, for sure, for
I mean,
sure,
you can prepare some content out of
for
it,
sure, for sure.
like a concrete example.
Yeah,
So basically, what we did is that we added a reentrancy protection. So unless the developer allows reentrancy to take place, to occur, reentrancies are forbidden. So it gets so what changes is that the execution is as the dev expects to be.
yeah,
It's basically impossible to have another piece of your code running. So stop running here, run it again from the beginning. That's exactly what reentrancy does. It's impossible unless developers authorize it. So for advanced developers that they say, oh, no, I want reentrancy, because reentrancy per se is not like something bad,
yeah,
but it's something that developers do not expect. So even if you get like a Solidity code that has a reentrancy issue, if you show it like to many developers, they're going to look, read, and say, no, it's safe. because they don't have the idea that a reentrancy can take place. Because in a regular where they are coding non-blockchain stuff, they don't. It's a blockchain thing.
Sure.
So thinking on the developers, we decide like, okay, let's add a protection. Reentrances are forbidden unless authorized. And
Maybe.
if a developer authorizes reentrancy because it's part of what they want, then they must know what they're doing. Otherwise, they can be subject to this kind of attacks.
Okay.
So if it's a feature for them, they allow.
It
If
makes
it's
me wonder.
not, so yeah, a developer that doesn't know what the reentrancy is will simply not activate it,
Yeah,
and
yeah,
he's gonna be these people, these developers, they're gonna be protected
yeah.
by this reentrancy protection that we added.
Ah. It's so simple, right? Like in the
Yeah,
sense that like I, I'm not too familiar on some of the other like the chain how the infrastructures of other chains, but like you'd think it would be a norm, you know. But as a industry, we're learning, you know. You only really learn from these attacks once they happen. You know, Ethereum itself is almost $1 billion just in reentrancy attacks. But what you're basically saying is, if I'm a Web2 developer and I'm getting into coding on full blockchain using, let's say we've just spoke about Python VM, like natively from the get-go, reentrancy protection is already going to be enabled, and they don't even have to worry about it. And at the point where they know what it is and they want to force it, they can check a box for it to be authorized. So it's kind of like, you know, like the options there, right? But like for the majority of developers, and if we anticipate a majority of the developers won't need reentrancy anyway, just leave it off, you know, like, and the risk is mitigated, you know. That's
yeah,
what
and I'd risk to add that many of those, they don't have a clue about what reentrancy attacks are, so they are protected even not knowing what they're protecting from. What's different is that if they're gonna code like something Solidity, they must know what a reentrancy attack is, so they can add a protection. So they must. That's part of what the learning curve. If they don't know, they can be subject to a reentrancy attack, and many are. See, you just mentioned like there's $1 billion issue only in Ethereum, like attacks, stealing money, uh, uh, exploiting reentrancy attacks. So it's not something trivial for most developers. And
sure.
we made a different decision when we were preparing our engine, execution engine. We said, okay, reentrancies are unauthorized, they are forbidden. Most developers, they don't know what it is, they don't need it, it's something unexpected and no obvious to them. So let's think about the dev experience. They don't have to learn about this. Okay, if they say, no, 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 I want to do this so I can have a callback, they can. They just have to explicitly authorize. They have to mark that, check that box saying, okay, I authorize reentrancy here. And
Yeah,
I know what I'm doing because if I don't, I can be attacked.
yeah,
So it's only for the ones that need it.
yeah. And I guess before we move on to the other point, it's like you've got the developer that's building a use case and maybe something like a Dex or whatever maybe, but then also the user as well, like because the user is affected by the reentrancy attack. Because I guess if the reentrancy attack happens on something that affects the users on the actual use case or
Yeah, it does.
wherever it affects both. It affects the trust and the trust and the almost the reputation of the developer on that actual use case, and because it's an exploit, and then anyone within Web3 that kind of gets used to these types of things, because it could be that it might be loss of funds through to a use case, and the use case may not reimburse funds to their user. The user gets infected at the end of the day. So
Yeah.
I don't know. There's loads of different ways you can look at it, but I think the way you guys have approached it is spot on. It's the safest way, and I guess again, building brick by brick, launching at a time where we've learned from everyone else's kind of mistake. There's a blessing in that as well, right? So and reentrancy is a great fun.
Yeah, your comment's very precise. Most of the contracts, most of the smart contracts, they hold users' funds. There is not only about the developers' funds or the company's funds or whatever, users' funds. And when an attacker is successful, everyone is impacted and trust rooms. and people lose money. The company can try to repay everyone, but many times they don't have the means
Yeah,
to. So it's like it's a shame. It's really bad for everyone.
definitely. That's with again with the whole you know being early in the space, decentralization, decentralization, and also a regulation to kind of not help those users and those types of scenarios take place. So as you just mentioned, spot on. So nice. We look forward to bringing more content on reentrancy, especially that example you said that's on the GitHub
Okay, and I guess
repo.
renters is just one example
One
because what we
example.
did is that we went through the list of most common exploits in other EVMs. And we added protection to some of those, to the ones that made sense for us. So we were thinking, okay, we don't have to have this. This is, of course, there are some use cases that want this. So forbid this and allow if they want. Someone must explicitly allow this kind of action. The reentrancy is one example. We can cover it later
Yeah.
in another tech talk.
For sure, for sure. And I want to touch on MEV protection. I know we've just recently put a blog out actually that we are the only MEV protection blockchain. You did mention it on the last tech talk. I know it's another rabbit hole we can dive deep on, but I'd like for you to, since we're on the topic of protection, to briefly touch on MEV protection as well for those.
Perfect. Yeah, that's a very good example of another kind of attack that takes place that they for Web2 developers, non-blockchain developers, they are not part of their model. They don't think about it. Basically, the MEV protection prevents because what happens in a blockchain is that how does it work? Like, of course, the UI, the UX, the user experience for many wallets and many swaps, liquidity pools, they are so good that you have this feeling that things are instant. So you click swap and like it swaps. You have this feeling that you click it there, it happened like atomically, and then it's done. But that's not how it works actually in a blockchain. Every action is encapsulated in a transaction. The transaction is propagated in a peer-to-peer decentralized network. So this transaction is propagated through many other peers. This transaction hasn't been executed yet, but the whole network learn about it. Everyone knows what you want to do,
Okay.
and but it hasn't taken place yet.
Sure.
It's still pending.
Yeah, yeah, yeah.
And then when the next block comes, your transaction can be executed. And then a block confirms it and it executes the transaction, and that's it. So what MEV does is that it uses this information about what you are planning to do to add other transactions that are gonna make you lose money and make me win money.
Yeah, well,
It can be a sandwich, one transaction before, one transaction after. It can be a front running, just like one transaction before. There are different ways of doing this, but that's what MEV does. So they kind of exploit the fact that operations in blockchains, each action takes a while to happen. And even though UI is really good and it gives you the feeling that it's instant, it's not. So they see what you're planning to do, not only you, everyone together, and they say, "Oh, okay, everyone is doing this, so if I do that, I make money," and they lose money,
yeah,
and they do. So what we did is that we added what we call MEV protection again for Web2 developers. It's very non-intuitive because on their systems, things are kind of instant. They don't have these trusting issues
yeah,
with a decentralized network because that's not how their execution works. It comes back also again to the execution model. So we are providing an environment where, of course, we are a blockchain, we are decentralized, so we have the same characteristic, the same feature that transactions are not instantly executed. But for a MEV attacker to succeed, They need to place their transaction before yours, or one before and one after. So they need to manipulate the order of execution of a set of transactions, not only one. And they do. Because in other networks, the order is set by the validators or by the miners, and so miners can be corrupt, and they can do this. I don't know if corrupt is a good word, but I guess it's kind of, because it's unfair to whoever is going to be robbed, uh, uh, and so they can manipulate the order.
Sure.
But we added a mechanism where they cannot. So the order of execution is unpredictable. They only know the order of execution after a block's mined.
Okay.
So even though everyone knows beforehand that I'm placing that transaction, attackers don't know when their transaction is going to happen. And many, many times in these attacks, if the attacker's transaction is executed in a different order, they lose money. So it gets riskier. They don't know when transactions are going to be executed.
Yeah, yeah,
So it's not a certain thing anymore.
yeah.
They
Sure.
can lose money. And
Yeah.
for many of these attacks to happen, like if they're attacking a liquidity pool, they need lots of funds to gain something.
Yeah.
But in other networks, it's a certain thing. So it's okay to allocate large amounts of money, because it's a certain thing that they're going to make, they get their money back and make
Yeah.
some profit out of it. But in our case, it's unpredictable.
Yeah.
So they can lose, and they can lose big. So the whole thing goes uh, 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 incentivizing everyone to not do it.
Yeah.
They can try. It's very likely that they're going to lose money. The attackers, that's what I'm
Yeah.
saying.
Yeah. It's like on Hathor, it's a gamble, and the house always wins, right? But like on the other chain, it's like it's predictable, and they just need to spend money to make money. And of
That's
course, because
it.
it's kind of like because it's kind of predictable, you hear about MEV bots and stuff, and they automate MEV, right? It's not just a manual thing. It's people have created code that is
Yeah. I-
malicious, you know?
I'd say that, again, it's about being aware of things. I'd say that most Web3 traders that are not taking action against MAV, they are exposed to MAV. And actually, they are losing money even if they don't know. Because losing money doesn't mean like they are necessarily losing funds, but they would profit $100, but they are profiting 30 because of the MAV. So this 70 that they lost was taken by somebody else.
Yeah,
They would profit more, and they're profiting less. So that's one. So I'd say that most today, if you place a trade in a liquidity pool in EVM without taking action against MAV to try to prevent a MAV attack, you are probably being attacked, even if you don't know.
yeah.
You think, oh, I'm out of luck. I did my math here. I was supposed to profit $100, but I profited like 20. And you think you're out of luck, but actually you were attacked.
Exactly.
Yeah, that's the point.
Wow. You know, again, I think MEV is a great topic. It's something I know you could speak a lot more on it as well. Um, yeah, it's interesting. It's interesting. Protection as this section from reentrancy, MEV. It's like putting everything in place to create a really safe, super environment on a very easy to build on blockchain. So I can see what you and the team have been working on in terms of not just like helping the builder build and making it easy for them to build and giving them the tools. Like when you think about nano contracts from a high level, blueprints and all pre-audited, you're actually also putting the things in place to protect them, you know? So it's great, it's
That's
great.
that's the whole point. Blueprints are another production layer that we haven't discussed here, but we can discuss another opportunity. But that's exactly what you said. Our goal is to protect the non-blockchain experts, the Web2 developer, and they have an execution model in mind when they're coding. and we want to provide an environment where that execution model is as precise as possible.
Sure.
So because math, again, math is just like reentrancy, is something that doesn't happen in Web 2. They don't mostly,
Mm,
of course, they can happen in very specific case, but mostly they don't. So
yeah.
it's out of their execution model from the developers. That's
Yeah.
why they are exposed to this kind of issue
Okay.
when they move to Web3.
Yeah. Well, it just goes to show, as well as having functionality, education is extremely important as well. But both go hand in hand, to be honest with you. And even with the education, if the chain you're using can't protect you so much, you might get stung. You might think you've not been stung. As you said, you may think you've profited less, but it's a huge chance that you got attacked. In a very subtle way. It happens ever so subtly.
You
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 know
can't even notice.
you can't notice.
Yeah,
You
it's a
think it's
shame.
just native to the chain. You may even attribute it to gas or something, like you really don't know. So
Yeah, it's kind of you are like the biggest fool, but nobody talks about it.
yeah, no one talks about it. It's crazy, and that's an educational thing. So Marcelo, touching on the last bullet of features we haven't spoken about, and then moving on to our closing because I know we're probably touching on an hour soon. Is native randomness called RNG. And I know there is probably some aspect of security in it, but it's mainly a function that is quite unique, I guess. Could you walk us through RNG?
Yeah, RNG is on blockchains is like random number generation, right? RNGs. It's like a complex topic. So what we did is that we are offering to developers a random number generator that they can simply access. It's a syscall. It's like a regular call, just like if they have like a random number library in Python or in your other languages where they can generate random numbers. And basically what we do is that we offer, uh, uh, well, many networks, they have like different ways of trying to do this. They use like oracles, external contract calls. There are many different ways that they use to try to overcome the issue of not having a random number generator. In our case, we each during the execution of each contract, we add a random number generator. I don't know if it's gonna get like too technical, but computers cannot generate random numbers. So we have like some algorithms that can generate pseudo random numbers, but it has like a starting point, which we call a seed, like the very beginning, the seed of the number generation. And what we're doing is that when a block confirms a set of transactions, the hash of the block, the hash of the hash actually, but it's a technical subtlety, is used to generate, it's part of the seed that's going to be used by the contract.
Sure.
So for the contract, it's impossible to see, to know which number is going to be generated. No one can know. And even for miners, because we are a proof of work network, we are not a proof of stake.
Yeah.
It's a huge issue in proof of stake because if they do something similar there, the validator is going to know the results before everyone. So the validator can, exactly as they do in Mav,
Yeah.
they can simply say, okay, it's not good enough for me, do it again. That
Wow.
generate another block, change something. Change a timestamp, change the order, change something subtle to change the random number generation so they can profit out of a contract. I don't know. Let's say like
Oh,
you build like a lottery. But in our case, because I mean, talking still about the other networks, validators, it's very, very cheap for them to generate a block.
sure.
Extremely cheap.
Okay.
So they can generate 100 blocks and see which one is better for them or for whoever is paying them to choose. That's how the math works, and profit out of it. In our case, we are a proof of work network. So miners are actually spending money, energy to find blocks. And there's no way to know what the number generation is gonna go, where it's going, before finding a block. But to find a block, they have already spent a huge amount of money.
Sure.
It's far away from being something cheap. So miners, they are in the business where they want to generate the next block, collect the rewards, and move to the next block. Because it's super expensive to keep a mining operation going on. Things can get on fire. The
Yeah.
hardware is expensive. The logistics is expensive. They need to have like a very safe networking. They have like 24/7 team of supports and people doing maintenance. It's a very expensive operation. So for them, they after they find a block and before they propagate the block, they know the results. But they've already spent their money.
Yeah.
If they decide to skip that block for any reason, say, okay, this one is not good for me, let me go for the next one. Probably another miner is going to mine that block, not them, and they're going to just lose their money for nothing. So in our solution, I guess we are offering, again, we are in the decentralized world, a decentralized network which imposes challenges, but we are offering a solution to generate random numbers that aligns with the incentives for miners. Miners are usually on the business of like getting the next block and relaying it as fast as possible so it doesn't become an orphan block so they can profit out of the work that they've done. So they are simply doing it over and over and over, which is a different thing when you go to a proof of stake network where miners are very cheap to run. Not miners, they call them validators, but the validators are very cheap to run and they can generate 1,000 blocks with like cents of dollars. So for them, they can cherry pick whatever is best for them. That's not the case for our miners. So that's how the solution works.
Sure.
And from the dev perspective, we offer a random number generator that they can use to build use case. They can build lottery systems. They can draw like I mean, I don't know what they're going to do, but I remember in Bitcoin they have an offline very interesting solution, very old solution. I don't know if it still exists. They called it Satoshi Dice. It was
Yes.
like a casino in a blockchain.
Yeah.
So it's very easy to build one using our random number generator, and we believe like it's safe for the
100%.
environment. Miners, it's extremely expensive for miners to take the risk of trying to manipulate the number generation.
I think I
Is
think
it
another
clear?
yeah, very clear. I think another one for RNG, I think I was discussing this with Jan, is NFT packs or like it's a big trend in like let's say football games like FIFA where on the non-blockchain side of things you play online, you acquire a pack and you open the pack like Pokemon cards. You don't know what card
Oh, okay.
you don't know what Pokemon card you're going to get, or just like FIFA, you don't know what player you're going to get, and that's what makes it really, really unique as well. Because that's just another ball game when it comes to like,
Oh, it's certainly a thing that can use our random number generator mechanism and do it like in a decentralized way
yeah,
in
yeah.
our blockchain. Definitely.
At least
Really cool.
yeah, on a PlayStation you don't get to really keep those assets or transfer them, but on blockchain you can, you know. So it's amazing. It's amazing. So I think look, we've touched on we've just crossed an hour. I know you've hit all the points extremely well, and you've educated us really well. And I think it is only right we do revisit some of these on a later episode, especially some of the new things we've spoken about. So Marcelo, before we close this off, I just want to give you the floor to give any closing comments on yeah, just in general the future.
Okay, yeah. First of all, I'm very happy to get where we are right now, where nanos are at the end of the auditing phase, and we're moving towards launching it. So I'm very excited about this. I'm very excited to see what people are going to build there. Like, I invite devs, builders, Web2 devs, Web3 devs to come and test, to see what they think, to try to attack. I mean, some people they can criticize some of our solutions. Okay, go there, find a way to attack. We have a bug bounty, help us.
Yeah, yeah, yeah.
But so far, I think it's really safe. So far so good. I mean, we haven't found any way of doing attacks. So please come help us, researchers, security researchers, come and test. And I guess people are gonna see how easy and how safe it is to build, and they will get excited. They'll just simply choose us because it's safe. Safety, in my view, it's a major thing for Web3 solutions. It's so hard. You have so many good developers doing unsafe codes.
Yeah.
They're not bad. It's simply a very complex environment. And that's exactly what we have in mind when we were designing and drafting and testing and coding nano contracts to get rid of these complexities and offer a safe execution engine for the developer. That's my message about nanos. So I'm very excited to see what they're going to do. On our end, Hardware Labs, Nano Contracts is just one step further. We have lots of other ideas and things that we want to build, and so we'll keep building, improving the wallet, the Explorer integration, trying to grow our ecosystem, our community, and everything. So we'll be there, still doing lots of things. We're not. It's not like a thing that ends. Even nano contracts, we probably can improve and add more features. We have actually, because we did the code freeze, we have a set of features that people requested, and I said, okay, later, not now, but we can work on them. So there are other stuff we'll keep building. That's the message. We've been building since 2018, non-stop, and we'll keep doing it for
Sure.
a long time. I hope.
I guess we just celebrated our first commit, right? Last week with the first commit of 7 years ago. Is that correct?
Yeah, it's this month.
This month.
Yeah, we are celebrating 7 years from the very first commit.
Yeah, I think yeah, was it earlier this month or it's upcoming, right?
I
I
guess
know
it's
it's
upcoming. I
upcoming.
have to
Okay.
double check. I didn't get
Yeah,
prepared for this.
yeah, 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 yeah.
I have to double check, but it's this month, and oh yeah, it's certainly something to celebrate.
Almost like so you got 5 years from mainnet, then 7 years from the first commit, and yeah, look, I think what you touched on as well, like I know nano contracts is a huge thing we're all waiting for. But it's not the be all and end all, There's so much more we can build from it, and like I said, Hathor as a network, we're like a cathedral, and the cathedral is looking beautiful. It's getting its vibrance, and soon it will be a tourist attraction, and people will be coming to, like you say, come and test it, come and attack it, whatever it may be. But for sure, with how things are looking, how close we are to mainnet, and then of course, I guess the other marketing team and so on will make it more vibrant, and we'll have a great launch in the near future.
Yeah,
But yeah,
and I have this feeling that because nano contracts, it's really more powerful than whatever I could imagine in 2019. It's a really powerful thing. And so I feel like for us, because we did like this strategy change, I don't know, 1 year and a half
yeah.
ago, something
It was a
like
couple of
this,
couple of years, I guess,
couple
from
years
the
ago.
yeah, a couple of years ago, right? I guess from the 1.5 to 2 year, I guess from the whole RWA stance, and even from what you guys built on that period is relevant to today. We've only in the last couple of months the first court order of 1 billion rares tokenized on our network, and
Yeah.
this is a snowball effect from all of the token Isadora and all of the other stuff, especially like you've got Kearney and so on with the organization of disasters and filing with consultancies, big consultancies like Kearney. So yeah, like you said, it was a change from around 2 years ago, right?
Yeah, I
Around
guess that's it.
yeah.
And it's like nanocultures are so powerful. I feel like it's just the beginning of our presence in Web3. So we have this goal to simplify blockchains. And in this case, for smart contracts, it's of course if it simplifies for it, it will end up simplifying for clients, for like users, for the community. But mostly we are simplifying for developers, for builders, because that's I guess that's the way to grow. They come, they build, and they build their own communities on top of our community, and it's like a virtual system, like where they come, they test, they build, they bring more community, they bring more people.
Sure.
So I believe like it's like, and I can say it's beginning again, but I'd say in Web3 it's like the beginning.
Yeah, it feels that way, like because honestly, from everything I've seen recently, like even looking at like everything from like internally, like we've put out screens from MetaMask snaps, for example, but seeing things like how everything will work, it's like all the pieces to a great foundation, like, and we could look at it as the beginning. We've been around, I've been with the team since 2021, and a lot of the work that we've done, aside from like nano contracts, smart contracts, and so on, like we said, there was a strategic change, but we did bring great flows in the RWA space, all based on the architecture we have. Tokenization is native to the network. These great features built from day one were able to, tokenize over 250 million on chain. And to this day, it's only the narrative that's just begun. So it is the beginning of something great. I think that's a great way of putting it. The
Yeah,
beginning
I
of
guess
something.
that's a good message. Yeah, I'm trying to say that I'm very excited for our future, and I guess we are providing a very competitive technology,
For sure.
and whoever tries, I'm talking about devs now, devs and builders, and whoever's developing or planning to develop a use case or use a blockchain as part of their use case, they're going to love what they're doing,
So
and it's going to be a no-brainer for them to use our technology. That's what I expect. So I'm very excited to see how it's going to unfold, and I'm very optimistic about what's going to happen. Let's see.
let's see. Well, I'm gonna put it to a hold there. I know we've just gone over an hour and we've covered a lot. But guys, if you've watched, thank you so much for your time. We will be bringing you more content on this, and we'll also be chopping this into shorts, break feeding it to you in sections over the coming weeks. And yeah, I guess Marcelo, I will see you aside from meetings on another tech talk soon, and we'll probably discuss more of the great things you and the team at Hatha Labs are building, as well as some of these topics we want to go a bit deep on. But until then, thank you so much for your time, and I guess we'll see you on the next one.
Yeah, thank you so much, Neil. It was such a pleasure to talk to you. I hope we could build a content that's really nice for our community, for our viewers, for the audience. I'm very, very happy to be here. Thanks again. It's always a pleasure to talk to you.
Likewise.
See you
Thank
next
you so
time.
much. See you next time. Thanks.